Here's a picture depicting the circulation around high and low pressure systems. This is a surface map, so we're looking down, bird's eye view, down on the surface of the Earth, and they've actually thrown in a few isobars here. Here's the 1028 millibara isobar, 1024, 1020. So notice as you get closer to the center of high pressure, the pressure logically gets higher, hence high pressure. And if you look at the other side, 1016, 1012, the pressure gets lower as you get closer to the low pressure center. The blue arrows indicate the wind direction around these pressure systems. So air is coming out of a high, moving in a clockwise fashion, and it spirals into a low in a counterclockwise fashion. That's what happens in the northern hemisphere. Looking at the same type of graphic, just at an angle, looking at more of a three-dimensional view, you can see what happens. Air aloft will come in and actually sink down to the surface, and as it sinks down to the surface, you see it spiraling outward in a clockwise fashion. Same thing on the low pressure side, it spirals in a counterclockwise fashion, and then as it gets to the center of the low, it rises up. And that's why you get a lot of inclement weather around areas of low pressure. You get rising motions. Rising motions are going to lead to cooling of the air. Cooling of the air is going to lead to condensation of the water vapor in it. Obviously, when you get condensation, you're going to increase your chances of precipitation. So low pressure associated with precipitation, high pressure associated with fair weather. This diagram here shows a photograph from the air of a small area of low pressure. And this is just an isolated thunderstorm, so it's a very small area of low pressure. But nonetheless, it is low pressure. You have rising motions coming up from the surface and then moving out in all directions once they get close to the tropopause. Notice above here, it's pretty much cloud free. The reason for that, this layer is probably the lower parts of the stratosphere. Remember, most, if not all, moisture in the atmosphere is confined to the lowest level, the troposphere. Above the troposphere is the tropopause, which is kind of an imaginary, or invisible, it's not imaginary, it's an invisible lid that keeps majority of the weather in the troposphere, and the stratosphere above it remains pretty much cloudless. So I've got moisture that's condensing because the air is expanding. When the air expands, it cools, condenses, and you see that manifesting itself as clouds.